Welcome and thank you for joining the Grain Storage and Cleaning webinar today. My name is Marla Carlson and I'm the Executive Director at Sask Organics and will be moderating today's session. I'm speaking to you today from Regina, Saskatchewan, and we're situated on Treaty 4, the traditional homeland of the Nehiawak, the Ishinapek, the Dakota, the Lakota, Nakota, and the homeland of the Métis-Michif Nation. So before we get rolling today, I'm just going to go through a few housekeeping points so that you can get the most out of today's session. So to improve the quality of your audio, you should close down any unnecessary programs that might be running in the background on your computer. All attendees are in listen-only mode. Only moderators and panelists can speak. However, if you have some questions that you would like to ask the panelists, which we hope you do, please pop them into the questions box there on the right-hand side of your screen. And if you have joined us by phone today, you'll been prompted to enter an audio PIN after joining the webinar. If you didn't enter the PIN, please make sure you're muted at all times. There will be some time for questions after each presentation. So it's a fairly short period of time, like just about 5 minutes. So we would encourage you, as you're thinking of your questions, to get them into the question box so that we can jump right to them when we get to that part of the webinar. And after today's live webinar, you will receive a link to the recording, and that should end up in your inbox within 24 hours, and will include any handouts that were provided to us by our sponsors and our presenters. And as always, please bear with us. And despite having done a number of these, there can be technical glitches along the way, and we'll do our very best to make it run as smoothly as possible for you. So a big thank you to our gold sponsor, Grain Millers. We really appreciate it. We really can't do what we do at Sask Organics without the support of our sponsors and our members, attendees like you today. And so we're going to get right into it because we have a full set of presentations for you today. So I'm going to introduce all of the speakers right up front, and then we'll just go from presentation to presentation. So our first speaker is Charley Sprenger. She is an agriculture research engineer at PAMI, managing a wide range of projects to help answer some of the questions that producers face about risk management and productivity. A key area of her research is grain storage and grain and drying management. So thank you, Charley, for being with us today. And following Charley, Stuart McMillan will be presenting, and he's the farm manager at Legend Organic Farms. The farm has a shared ownership structure with Nature's Path Food and is committed to using innovative and regenerative methods to meet sustainability and production goals. His past involvement in the organic sector has included inspection, certification, consulting, analysis, and research. And our final speaker for today will be Dwayne Woolhouse. He is the owner-operator of Crestview Organic Farms, which is a certified organic farm located near Assiniboia, Saskatchewan. The farm was first certified in 1992 and is a family business, everyone playing an important part of ensuring the highest quality product is produced each year. The farm grows and processes a variety of organic grains and value-added products. So without further ado, over to you, Charley.
Perfect. So I think everybody should see my screen now. There we go.
Yeah, we can see it.
Okay, perfect. So thanks for having me here today. We always love joining these webinars and speaking on grain storage and drying. So this one here today, I'm going to go over our standard presentation on the basics for grain storage risk management. So really going over the basic principles and walking through what's important for managing risk when storing grain, regardless of what crop. There we go. So just an introduction to PAMI first. So for those of you who aren't familiar, PAMI stands for the Prairie Agricultural Machinery Institute. We're an applied research, development, and testing organization serving stakeholders in the ag sector across Canada and North America. We do a lot of third-party testing of equipment at both our facilities in Humboldt, Saskatchewan, and Portage la Prairie, Manitoba. And specific to grain storage, we conduct both bench and farm-scale grain storage and drying research projects to help develop better management practices for producers to use as risk management tools. So this presentation, like I said, I'm just going to go over the basic grain storage and drying principles, talk a little bit about how we can extend the drying season using some supplemental heating. And in inclement years, this one, fortunately, we had a good harvest year, but others we haven't. And then touch on some technologies for monitoring stored grain, as that's a really important part of managing risk. So really, what's the issue? So hot and or wet grain can spoil during storage. We know this. It is both moisture and temperature that can result in spoilage. And ultimately, spoilage means lost revenue. So it'll look either moldy or clumpy or smell burnt, and you definitely know what. Often you find out when it's too late. So trying to apply some of these principles to mitigate that as soon as possible. So the Grain Commission has put together these safe storage conditions for all crops. The link is here, so you'll be able to reference that to look up for each crop. I've got flax and wheat here just as examples. But here it shows that we've got moisture on the vertical axis and temperature on the right, and indicating where those safe conditions are for mid to long-term storage. And outside of that, we get into a risk zone. Keep in mind on these charts, it says no spoilage in the green zone, but really it's reduced risk of spoilage. There's really no point where you can guarantee that you won't have any spoilage. It's important to monitor and manage it at all times. Typically 10 degrees Celsius is a safe storage temperature across the board for long-term storage. So how do we control temperature and moisture in the bin? We blow air through it using aeration fans. So just a quick terminology, so we're all always talking about the same parameters. So when we refer to aeration, that's used for just temperature control, to reduce the temperature and even out the temperature profile in the bin. So typically this is when your grain is dry coming off the field, and we just want to cool it so it's safe and we don't get any hot spots developing. We use low airflow rates, about 0.1 CFM per bushel, and run the fans when the bins are loaded. But if the grain is coming slightly tough off the field, not quite dry, we do have the capacity to dry grain in bin using the ambient air, and we call this natural air drying. And I'll go through some of the other principles for certain conditions when this is suitable, but ultimately it's when the air has a capacity to dry, it will actually dry the grain in the bin. We do need higher airflow rates to make sure we're moving that moisture from the bin. And then lastly, when we talk about heated air dryer, this is using an actual batch or continuous flow dryer at high temperatures and much higher airflow rates to dry grain before placing it in the bin, and you cool the grain before you place it in the bin to make sure we have both dry and cool grain. So really the main difference between these three strategies is airflow rate, I mentioned. And so what kind of effect does it really have on drying rate? So here's just an example of some data we collected on one of our tests for a trial, and it gives a really good indication. You can ignore the yellow lines for temperature, but on the top, this gray line where I've labeled aeration, that's our low airflow rates. We really don't see a lot of drying occur. It's more stable. But if at our higher rates, 1 to 2 CFM, we see drying occur. This is a fairly exaggerated. We had very ideal ambient conditions to dry the grain, so it's a little exaggerated, but you can see by increasing airflow rate when the outside air is the same condition, we really achieve more drying at a faster speed to manage risk quickly. But how do we know how much airflow we've got in our bins? This depends on resistance to airflow and the conditions of your specific bin. And resistance to airflow is the amount of pressure that the grain in the bin exerts back on the fan, so that you know how much, what horsepower of fan that you need to achieve the airflow you're looking to have. So the things that impact resistance to airflow that we can use to determine what our estimated airflow is so the grain type. So each type of grain has different, because the seeds are different sizes, so too is how they pack and the amount of airspace between the kernels and how easy air can flow through the grain bulk. So these charts, I will give a link at the end to our website where we've got all these resources, but we've got all these tables set up for each of the different main commodities that you can reference. Second is grain depth. So in this chart, you can see that as the grain depth increases, the resistance in the grain bulk to airflow increases exponentially. So it's much easier to push air through a lower grain depth, and that'll mean that you can dry grain faster or cool it down if that's the case. Airflow rate, so the faster you try and push air through the grain, the more back pressure there also is. So when we're trying to achieve those drying airflow rates, we will need more power to overcome that resistance. And then the last thing that impacts is the distribution system. So depending on what type of ducting, whether it's a rocket system, fully versus perforated, this will take into a little bit extra resistance, but it's fairly negligible for the most case. But it is something to consider. You want to probably round up a little bit when you're sizing your fans versus rounding down, just to take that into consideration. So now that we need to know the resistance, there's a couple different ways to measure this. So you can either use, it's originally based on this YouTube manometer to measure the pressure, but there are gauge dial systems, some of which you can get specifically made for your bin, so you don't have to convert that. Or you can get digital systems, and you essentially connect it at the fan outlet between it and the bin to measure the pressure between the fan and the bin. And then you can use either those charts and your fan curves specific to your fan that you've got installed on your bin, or there's also a handy little tool that the University of Minnesota has developed for sizing fans, and you can input your static pressure, your bin size, number of bushels to determine if your fan's sufficient for whether you need that higher airflow rate for drying or if you just need it for aeration. Or in the case if you were wanting to size a new fan for a bin, you can make sure that under your worst case scenario, as for example, small seeds such as flax and the highest depth that your bin could hold, make sure you have enough power to aerate your bin. A few of the other considerations and challenges when we're looking at aeration and drying to keep in mind are, as I mentioned, that small seeds mean quite a bit higher pressure. So in larger bins, in canola, which isn't as relevant to organics, but that will increase the pressure a lot higher. So that's your worst case scenario. If you do need to dry consider filling your bins not as full, or using smaller bins as drying bins, and then store in a larger bin for long-term storage once it's dry. Layering is also something that can happen. This is more of an impact on larger bins, but as you take grain off the field, different times of the day, you might have different properties or different areas of the field. Perhaps there's a region with higher dockage, that those layers will affect uniformity and therefore drying performance. You might have lower pore space to allow the air to move through, or in the next point, actually the last one I'll skip to, so green seeds, so if you have immature spots, variability, those can result in high moisture pockets in those different layers, and so that can cause heated bins. And then jumping back here, certain oil seeds and pulses will also respire for up to 6 weeks after harvest. So keep in mind that it could be dry at binning, but that respiration can cause additional moisture that could result in hot spots. And so it's important to monitor in case that's occurring, and may have to turn the fans back on if that's evident. The last couple to keep in mind that we've looked into that might have some impact are how the grain is filled. So naturally it piles into a cone, and because static pressure is based on depth, the non-uniform profile can impact. But if we were to use a spreader type to even the cone profile, it creates a different void profile that's uneven. So things that we're investigating don't have specific recommendation, but it's something to keep in mind that there's different options. Our best recommendation is to fill, and if you're able to level out the cone once it's full. Ventilation in the headspace is very useful to make sure that the air that we're moving through the grain bulk, especially if we're drying, can actually exit the bin, so we don't have any pooling of moisture at the top of the bin, and also make sure that there's no extra back pressure being caused. The recommendation is about 1 foot square per CFM of ventilation. So the age-old question of when to run our fans, in the specific case of aeration fans, they should be turned on if you can as soon as you start loading the bin, even if the outside is warm, to keep hot spots from forming, and let it run until it cools off. Otherwise, keep it running through the evenings when it's coolest, and using those low airfill rates. And our rule of thumb is run for a minimum of 24 hours, or if you have monitoring cables or system, until that temperature profile is evened out, and monitor to know if you need to turn them back on. I'll come back to some recommendations for when to run your fans for drying once I go through the next few slides. So as I mentioned, natural air drying is what we refer to using the natural ambient air to dry grain in a bin at ambient conditions. But how do you know when the conditions are favorable? We use a little water glass analogy to describe when the air has a capacity to dry, and it depends on how much water the air can hold, and that's a reference of temperature, and how much it's currently holding, which is its humidity. So if we look at warm air, we can consider that to be a tall glass, and if we have a 60% relative humidity, it's a little over half full, but there's quite a large volume remaining to fill the cup back up. However, with cool air, that would be represented by a smaller glass, and 60% humidity, it's still just over half full, but the actual volume that it's able to hold is smaller. So even though the humidity is the same, the actual volume of water that it can take up is quite smaller. So when the air has capacity to dry, is typically we're referring to the amount of water holding capacity that the air has. So in order to make this a little simpler, there's a whole bunch of formulas depending on what commodity, what the air temperature and humidity is. So each different grain type has a different chart. These are also available on our website as references. Here we've got wheat as an example, and we've got humidity across the top and temperature across the side. And so, for example, say the humidity of the air outside is 70% and we're about 10 degrees Celsius. We look to see where that is on our chart to see if we ran our fans using this air, what would the grain conditions reach over an extended period of time. In this case, we're looking at 15.7% moisture. And unfortunately, this isn't considered dry for wheat. We want to look at something under 14.5. So this would not be a good, the air would not have a capacity to dry in this case. So what we're looking for and when to turn our fans on and know that we will see drying occur is when the conditions result in moistures lower than our dry safe storage condition, in this case 14.5 for wheat. So we're looking in this range, so about relative humidities less than 65% and temperatures around 10 to 20 degrees. Even though there's EMC, equilibrium moisture content values less than 14.5 at the lower end of this chart, we usually don't consider those because anything, as a rule of thumb, air temperatures less than 10 degrees, the rate of drying becomes very slow, so very inefficient. So if you're really concerned about managing that moisture to risk spoilage, drying will occur, but it'll take a lot longer. As a rule, natural air drying takes about 1 to 2 weeks to fully get to dry, depending on how much moisture you're trying to remove. Usually we recommend nothing more than 3% above dry, but if you were to try and do it at low temperatures, it would extend that much farther. So when is the best time to run the fans? Do you run them just during the day, only at night? Don't turn it off until it's totally dry. And really the best strategy is dependent on a lot of conditions. Every situation is unique. As we see, the properties depend on what type of grain you've got, what's the starting moisture of your grain, what's the grain temperature, and what are the ambient air conditions. And it's really been a debate for lots of years. Different theories have been thrown out, but really there's no universal answer. It's complex. So trying to use these principles and look at your specific scenario and those EMC charts to determine when to run your fan based on the ambient conditions and your bin scenario. But as a general strategy, if you want to achieve safe storage for any grain type in a variety of ambient conditions, the recommendation is to run your fans continuously so that on average, you'll eventually achieve safe storage conditions. And by not turning them off, you don't run the risk of partially moving moisture out of the bin, but then it's getting stuck and sitting in a pool of moisture halfway through the bins. It keeps moving air through, so you won't get grain heating. If you want to have the minimal fan hours, this is when you would only run the fans when the air has a capacity to dry. So really looking at those EMC charts and only choosing to turn your fans on when you have capacity to dry. There are different systems available out there that can control your fans to take this into consideration. And if you just want to cool grain, as I mentioned, run them continuously if you're using low airflow, or if you had higher capacity fans, you could run it at night only when the air is cool to speed that up. So I'm just going to go through a bit of information on supplemental heating. I won't spend too much time, but it's good info, and we've got some other frequently asked questions fact sheets on our website if you're interested for more details. But really, what we can do is extend the drying season by adding heat to these in-bin aeration system when the ambient air doesn't have a capacity to dry and we don't have good drying weather later in the year when we might have a late harvest, or in the case of if it was a rainy year and it's really high relative humidities. The rule of thumb and principle that we're working off of in this case is that anytime we increase the air temperature at the inlet of the fan by 10 degrees Celsius, the RH of the air is cut in half. So if we look at this cup, if we had a high humidity, low temperature scenario, so a full glass, not much holding capacity, but if we warm that cup up, we increase the total volume, but we don't actually add any more moisture. So we have lots of space to take up air and lots of drying capacity added. If we look at the chart, this scenario, we see 70% humidity, 5 degrees Celsius. We bump that temperature up. Now our EMC is down around 10, so we're going to see a drying rate trending towards that 10% moisture, whereas we wouldn't have seen any drying occur at the original condition. So the keys to using supplemental heat, we have to keep in mind that it's not the same as using a heated air dryer because we don't have that as high of temperatures and we don't have as high airflow rates. We're typically looking at airflow rates around 1 CFM per bushel is realistic on these in-bin aeration systems. So we're shooting for temperatures between 20 and 30 degrees Celsius. The temperature is what draws that moisture out of the grain kernel, and the airflow rate is what helps moves it out of the grain bulk. So we really want to match these two different rates. We don't want to add too much heat that we remove all that moisture from the grain, but not enough airflow to actually remove it out of the bin, and we end up with pools and layers of moisture sitting in the bin. There's different ways to add heat to a natural air drying aeration fan. Different sources of heat, electricity, propane, natural gas, and it can be done either indirectly using like a heat exchanger or directly by the heat flame is used to directly heat the air. Sometimes there's concern from producers that know that by combusting, the byproduct of combustion is water and carbon dioxide. So saying, well, if we're producing water by burning fuel, is this not counterproductive? We're adding moisture to the air. But if we do a quick calculation on a comparable system to a medium hopper bin using adding 10 degrees and a 1 CFM rate, we'd be adding about 7 pounds of water per hour. But if we look at the amount of drying that we're doing, we're removing at least 10 to 20 times that amount. So the amount of moisture that we would be adding to the grain by combustion is negligible on the grand scheme of things, especially because you could turn a bad drying day into a good drying day, whereas you wouldn't have had any drying capacity to start with. So these are some just examples. You can also install upstream or downstream by installing something before the fan upstream. It is easier to implement and it can be retrofitted or moved between bins, but there tends to be more inefficiencies. You have more ducting to get that heat from the heater to the fan. Downstream heating, it's more energy efficient for this reason because it's installed right between the fan and the bin. But you can't move it between bins as easily without a full reinstall. And then this is just an example image of a, in this case, a dry air system as an indirect system using a heat exchanger. You could theoretically hook several bins up to the same system. We can go, I'll just quickly touch on some of the calculations that you would use to make sure that you're sizing your heater correctly for your scenario. Depending on what units you're looking at speccing your heater in. This one outlined in red, BTU per hour, is pretty standard. And we're looking at how much heat you're wanting to add and the airflow rate that you want, and then there's a conversion factor here. It's 2.05. And so this is what you would use to understand how much BTU. This doesn't account for heat transfer losses, though, which I'll touch on the next slide. So for this example, we want that same scenario. For example, a 5,000 bushel bin, 10 degrees increase in heat temperature and 1 CFM per bushel. Plug that all in. We need about 100 BTU per hour. So that's what we need to make sure is available to the bin. If we look, for example, this heater might have a 66% efficiency. So once we take into account conversion losses and inefficiencies, we need to make sure we have a heater that's sized about 150,000 BTU per hour. So lots of questions about how efficient are in these supplemental heating system. They're becoming newer to use. So there is work currently being done by Team Alberta and the different commodity groups with support from PAMI to help benchmark some of these different configurations. But if we look at the theoretical efficiency is about just shy of 1,000 BTU, and we've done some benchmarking of grain dryers with batch and continuous, and the actual efficiency of those is about double the theoretical. The expectation and what we've seen so far is that the faster you try and dry a grain, such as a heated air dryer, the more
Oh, we seem to.
output.
Sorry, Charlie, we were just having a bit of a freeze up there. We lost you for a few seconds, but you seem to be back now.
Okay, I noticed that. Did we miss anything or?
Probably just the last 5 or 10 seconds, I think.
Okay, so I think I was just mentioning that for using our, so more energy required to dry grain faster. So we're looking at hours for heated air drying, but with our supplemental heat system, we're days or weeks, but overall more efficient amount of energy per pound of water removed. So one of the questions often is when deciding whether to use a heater or invest in a dryer or a supplemental heat and natural air drying system is cost. Doing an in-bin system using your fans is much less of a capital investment. And if you don't have a lot of grain that needs to be dried on a regular basis, this could be a good alternative. But we do have to keep in mind the cost of fuel impact. So this is an example of a grain drying cost calculator from Manitoba Ag that they have available just as a tool to benchmark for drying grain using a dryer. But if we look at that scenario we've been considering along, first off, natural gas compared to propane, depending on what's available for you. Here in Manitoba, natural gas is not nearly as readily available as Saskatchewan and Alberta. So propane is often the option, but it's quite significantly higher. These are a little outdated numbers, but overall the reference between the two is pretty similar. So really, if you have to use propane, your cost per hour is significantly higher. And in just to compare, the cost of electricity to run those fans in this scenario is about the same as the amount in natural gas. Also, we have the potential for supplemental heating to be as efficient without the capital investment as using a heated air dryer, but it has to be managed properly. So we have to make sure that we're only running it when the air has a capacity to dry and we're adding an appropriate amount of heat because since it is a longer duration, if it's mismanaged and it takes much longer to achieve drying, then we can actually become more inefficient from an operations perspective. So these are the guidelines that we've put together as management practices. If you're using supplemental heat, make sure you only use certified heaters and follow instructions. You don't want to dry your grain to minimize the risk of spoilage, only to risk setting it on fire. That would not be good either, so make sure you follow instructions. Ensure adequate airflow. Minimum of 1 CFM per bushel is our target. Plenum temperatures of about 20 degrees Celsius. You can go higher than that if you have capacity, but make sure you bump up your airflow rate as well. Make sure your fans can achieve that to match the drying conditions. That rule of thumb that for every 10 degrees you add, RH is cut in half. So even if it's raining, if it's still safe to run your fans, you can cut that humidity rate down and you might actually still be able to keep some drying going and not have to turn your fans off. Make sure you have adequate ventilation. You don't want that moist air that's being pulled out of the grain bulk to condense on the bin lid and run back down. So make sure enough ventilation so it actually can escape the bin. And anytime we're heat drying and adding heat, make sure you cool your grain back down before long-term storage. And most important, make sure you monitor the grain temperature and if you're able to moisture to prevent overheating and over drying and to know when it's reached a dry condition. Speaking of monitoring, I'll just touch on a few examples that are out there. So for monitoring the bins, they're the standard temperature and moisture sensors on cables that are quite common and different manufacturers of those. And also can be tied into those are some fan control systems. So using the temperature and moisture information that the cables are reading, being able to automatically adjust your fans to decide when to turn off or on if the conditions require it to. And then so other programs that'll allow that'll monitor the ambient conditions and do the work of indicating whether the air will have is forecasted to be good drying conditions, so that to decide what to turn your fans on but you can also reference those charts yourself and manually turn your fans on or off when it's suitable. And as I mentioned, yeah, different control systems. Say you only need cooling, or if you need drying, then it can monitor and manage based on that. To keep in mind, some of the limitations of these systems are that, so any sensors and communication can fail. So once your grain's in there in the sensors, if one sensor fails, then it's really hard without emptying the bin to troubleshoot. So a little bit of potential errors on that end. And also the insulating capacity of the grain does limit the amount of grain that can be monitored by a single sensor. So there's a radius, so especially with the cables, depending on how big the bin is and the region that each of those sensors can monitor, there could be blind spots that aren't being monitored. You could add more cables, but then you also do run the risk of having too much pressure load on the roof of the bin. So just something to keep aware that you might have blind spots. But one of the potential solutions to that are the grain viz system is quite new, and it uses different sensors along the wall of the bin to get essentially an MRI image of your bin to look at the moisture conditions. Typically I have this as a video, but I've taken that off for this presentation, but it just shows the different profile of the bins. So you can slightly see an orange region at the top, which would be a higher moisture, but we're starting to see grain drying at the bottom and slowly drying as the air moves to the top and take the moisture out of the bin. So that's definitely one that would be quite a valuable technology. And then some other ones that are kind of emerging and out there, kind of a combination of using these small wireless, sometimes they're called beans, or little sensors that are free floating. You could add a whole lot of them into the bin and get more visibility and collect data. And it could also, there's potential to add in an element of traceability into your operation. And perhaps in the case of organics, this has potential down the road for you can keep these sensors along with the grain, and they can travel along the supply chain to show where that grain came from, and then eventually be separated out before it's processed. So something emerging, nothing out there at the moment, but something we and other companies are investigating is where they might fit in the market. So that's kind of the highlights of the monitoring, and I think I'm just wrapping up here and want to leave you with some key takeaways. That being that all grain storage and drying scenarios are unique. There's no universal rules about when to turn your fans on. There's some general guidelines, but really the best way to minimize risk is to use these principles to make sure you're managing your bins appropriately and based on your storage goals and your individual scenarios. Supplemental heating can be used to help extend the drying season. Make sure you've got enough airflow rate and you manage it properly so that it's efficient, but can be a good low capital investment for years when you need extra drying and it's cool and damp weather conditions. But most of all, monitoring is really critical. If you are able to install some sort of monitoring system, regardless of what management practice you're using, the more information you have, the more you can make good informed decisions. And really any monitoring system is better than nothing. Kind of just a highlight of some of the things that we're doing right now. I mentioned that we're doing some benchmarking of these supplemental heat systems with Team Alberta. We've developed lots of different best management practices for your main commodities, wheat, canola, and peas and lentils, other commodities, and right now we're working on hemp. And then some of the things we're looking in the future is to add just more information on the impact of different monitoring technologies, different plenum designs, to use multiple fans to increase drying capacity, and different ventilation systems. And also BMPs for non-traditional crops. So if there's specific crops that are of interest to you that might behave differently, that don't fit into one of the current categories, then that's something we want to look at too. Intercrops are also a different scenario that we've done a bit of initial investigation into, in the case of if you have to store them as a mixed crop, what's the implications of that? And then, so this is where you can find all of our PAMI reference material that I've talked about throughout the presentation. So we've got some presentations, all of the different charts for all of the commodities, some how-tos and frequently asked questions that you can access, as well as we have the charts for the EMC values for each commodity, but we've also developed a calculator recently that you can just plug in your scenario and it'll spit a number out rather than having to work on the tables. We have been made aware of a couple of glitches, so we're working on troubleshooting to make sure everything's good, but your main commodities seem to be good. I think it's just peas perhaps that we're having issues. But I think that's it for today. So just really high level highlights. Anytime feel free to give a call or an email if you have specific questions. We like to help with extension and working through individual scenarios to help you for your specific conditions, developing those management strategies. So, but I'll take any questions if there are any. I believe Marla was.
Yeah, perfect. Thank you so much, Charlie. Very information rich. Thank you so much. It was a great presentation, and knowing that there's a lot of resources on your website as well to help out is very helpful. And Deb will circulate the link to that when she sends out the webinar recording in the next 24 hours. So we do have a couple of questions. The first one is, has PAMI done any recent research with solar drying, that is using solar air collectors to supply fan intake air? And if you haven't, do you have plans to do something on solar?
Yeah, no, we haven't done any specific to solar recently. I think there might have been some preliminary investigation quite a long time ago. It's definitely something that, especially with the impact of carbon tax and different fossil fuel based sources, trying to find more efficient or sustainable tools. So it's definitely one that's becoming on our radar. But as of right now, we don't have any projects lined up to look at it, but definitely something we'd be interested in doing.
Okay, no, perfect. Are there any benefits, drawbacks to storing intercrop grain long-term in the bin, canola, pea, or oat lentils?
Yeah, so I can't remember off the top of my head. We did take a preliminary look, and if anybody wants follow up on this, you can send me an email. That does depend on, there are certain combinations. I think pea canola is okay longer term. If you look at the EMC scenarios for each of those, there's overlap in where the safe storage conditions are for safe storage scenarios. I don't recall for flax lentil, but we did a couple different scenarios. We haven't done any testing, but based on theoretical, our estimation or recommendations, we do have some input.
Okay, perfect. And our last question, would there be an advantage to circulating grain in a bin while drying?
Yeah, so there's sometimes been a recommendation to turn the grain, or probably it's kind of mixed opinions. We haven't been able to do a full test to understand, because when you turn your grain, you've got, if you had a mixer, that could help. But as far as that layering effect, over drying occurring at the bottom, because the bin will core as you pull it out, then you're putting dry grain back at the top, and now the moist grain has farther to send that moisture out. So we recommend drying in smaller batches so you don't have that impact of this drying layering occurring and then storing your dry grain in a larger bin. So, but hopefully going to answer some of those questions better soon.
Yeah, no, perfect. Thank you again, Charlie, for being here today and for your presentation. And yeah, more information to follow to folks who've registered. So thank you again. And
You're
now
welcome. Thanks for having me.
Perfect, thank you. And now we're going to hand off to Stuart McMillan, and he's going to share his experiences using the Quick Clean Grain Cleaner in his operation. So thank you so much, Stuart. Over to you.
All right. Well, perfect. Thank you so much for the opportunity to speak here today. We want to make sure everything is looking good on my side. Hopefully, my apologies. This is the first time I've ever done a webinar-based presentation, so this is definitely a little new for me. So that's also it's some of you may have heard me speak before at Organic Connections or within Sask Organics. It's a great opportunity to speak about something less cerebral and theoretical, and talk about something where I just like particular bolt sizes. So certainly it's a very different opportunity here. So with that, I will get rolling. Okay, so is my screen showing properly now?
It is.
Okay,
thanks.
perfect.
Yeah.
That was my unknown here. So excellent. So I guess I could have made this just as easily the rotary cleaner presentation. There are certain similarities. I've used a rotary cleaner at the farm I was at before. Certainly has some applications, but we have a quick clean here, so ended up as a quick clean presentation. It really is about looking at simple on-farm cleaning, though. And I mean, there's some very basic sort of scalpers that I can become aware are actually available now too. The rotary cleaner has some applications, but where the quick clean, I think, fits in for organic grain farms, it's mobile. You can move it around as you need. It's relatively affordable. So in that point, it's sort of fairly limited commitment from a financial scale, ease of placement and storage. Where I like the quick clean over the rotary screener or the rotary cleaner is that there's, I think, greater cleaning options due to an increase of different screen options, both in screen sizes and screen design. So just kind of looking at some of the setups we have, you can kind of see to the right there a veritable mountain of wild mustard, wild millet, and small fines getting pulled out. And yeah, I think with having sort of a quick clean, it does allow a variety of different setups depending on your binyard configuration or how you're using it, whether it's coming directly from the bin, as we have in this case, with a sort of a little transfer auger, then into the cleaner, and then transferring out your screenings into one truck and your clean grain into another, or can also come directly from the trucks into the cleaner as well. So I guess why? Really, and I'm sure Charley touched on this a bit, and we'll also hear from Dwayne on this. I would say the reasons for use are similar as you would with a larger fixed cleaning structure, in the sense that it allows you to remove your dockage to improve airflow in your intended crop. As Charlie pointed out, that really changes the movement of air through your grain mass. That said, we're typically not using our quick clean at harvest. Typically, we will get our grain dry, get it in the bin, and then goof around with it once everything's done. But you could do it the opposite way, especially if you knew you were running into a high dockage scenario that was going to impact your drying. You could certainly knock some of that out right beforehand and really have a much more uniform crop for drying. Obviously, it reduces spoilage risk, particularly as I've found sometimes my dockage will say have grain is dry, but then you get mature alfalfa or alfalfa seed heads that are on its way to being mature, but are still kind of green. So you get this large variation under organic crops in between your moisture levels of your dockage. Obviously reduce shipping costs on grain depending on your buyer contracts. If you're just if you have to have a certain dockage spec and you're shipping over that, you're shipping product that you're not getting paid for. And obviously it creates marketing opportunities for your dockage. So rather than shipping it to somebody else and they sell the dockage, keep it, sell it yourself. And I do think too, it expands your cropping options with intercrops. We've certainly used the quick clean in some pea and cereal combinations. We've tried it with a wheat flax combination with greater, some degree of success and failure. And I think also one of the things is it creates marketing opportunities for primary crops with specific dockage tolerances. Thinking back to, we had some movement opportunities for peas. Buyer needed it under 1% dockage. Organic production typically coming off the field of peas. I don't know about any of you, we're typically not under 1% dockage, but we were able to take peas from 9-10% dockage down to 0.05 and thus got the sale that we wouldn't otherwise have had, or would have had to go find an off-farm cleaner. So just run through a bit of the principles. So you've got your dirty grain coming in, whether it comes from the bin or the truck, goes into a hopper, and then from the hopper, there are a number of tubes with removable and changeable screens. So your mixed material flows up through the tube, if you can manage that, and then the screenings all comes out the sides and then collects from the bottom and goes out the paling, and clean grain on the end. You could reverse it around depending on what you're trying to knock out. Dockage could go out the other side. The palings auger is relatively small capacity. I think it might be a 6-inch. I don't even know if it's that large, so that is a bit of a limitation, but I have seen people where the auger is foldable, so you can just fold that narrow auger out, have it, the palings region still just say spill out into a large Big Daddy hopper or something like that, and then put a larger capacity auger from that hopper. So that is also an option. This picture is from the manufacturer down in North Dakota, and they highlight the agitation tabs on the augers. It's obviously a new feature. There's a couple of new features that I've seen, not on my model. So new and improvements are available for those out there. So as I say, there's two different models, 5-tube and a 7-tube. Tubes are the same. You can see the specs there. Won't run through them all. Principal one being that they say the 5-tube can handle about 2,500 bushels per hour. The other one at 3,500. I think those are vast overestimates. 250 might be a more reasonable number. But I guess it depends how much you're trying to clean out and what you're trying to clean out. That's a big variation. Seems on hearing from other producers between 5-tube versus 7-tube. By the way, we have 5-tube. Not a great difference in cleaning capacity, but according to the manufacturer, there's a significant one. So I would say the jury is out in what the manufacturer claims versus what the chatter on farm social media would say. So I mentioned the greater cleaning capacity. This is where I think it really kind of creates opportunities. So you can swap out those screens And we're at the point now we have probably 4 different sets of screens as you kind of find new scenarios. If you really were if you're principally were just say wanting to knock wild mustard and wild millet out of your large seeded crops, well, you can probably get away with just one of these small rounds, the 5/16 round or even the 6/64 round. But you know, the 5/64 probably just knocks out the majority of things. But if you have any degree of different commodities you're going to be running through, you will end up really wanting to have a couple of different screens depending on that. Yeah, so as I say, the variety of screens do allow a wide range of dockage removals. We've certainly have, even in our complex mixtures, run different passes with multiple screens. If we're dealing with something really complex, sort of fine material, then knock out the large or vice versa. So changeout procedure, as I say, that's a very, very applied presentation compared to some of mine. So I love the fact that all of the nuts are 1/2 inch as you're going through this. So when you're going through the clean out, you got 1 wrench and 1 set of sockets as you're going through. There is a potential, if you really are rammy, you could potentially distort your tubes, and you don't want to do that. You do need to be cautious when removing the slotted tubes. That's where I find it is actually better as a 2-person job. 1 person hold the auger while the other person massages the tubes out. But it's relatively quick transfer once you're experienced. If you're like completely 2 hours all in, should be with 2 people, and that includes cleanup time. But they have made a new design feature that allows you to just, it's a quick open slot that allows for easy clean out when finished, which would reduce that even further. So these were some photos that I took here this fall, because after being asked to do this presentation, well, we had some commodities to clean up. So I thought it was a perfect opportunity to snap some pics of the Quick Clean in use. So as you can see, once you go through, you're going to remove the bearing plates as well as the other plates. Then you get access into the augers. So that's where you've got, you know, narrow, what's that, 35 nuts to do on the one side, a couple of other clamps. You're kind of got about 45 nuts to remove. So it is nice that they're all the same size. Then you've got access through tubes. You can see the augers that are in there. As I say, these do not have agitation, tabs in there. They're just sort of standard auger. Then you slide the tubes out and then slide your tubes in. So the action, we'll take a quick video and we'll see how this works here. Hopefully audio is okay and it's not problematic, and I may be able to start and stop it as we go. Oh, I see. Videos worked in PowerPoint, but they don't seem to want to work here. Well, darn. So really this was just going to show then the screener in the Quick Clean in action. So I'll walk you through it. So I like to find that bottom hopper to try and fill it up as much as you can, so it pushes the grain onto all of the tubes. If you have the hopper, so it allows the grain to just flow directly from the truck into the cleaner and not fill up that hopper, it tends to just travel down the main tube, and you really don't get full cleaning action across all 5 tubes. And you really want that the screenings will be coming out both the top, sides, and bottoms of those tubes. So that's where you really want to push the grain through. And you would have seen some nice clean peas coming out the other side. That's the other comment I would learn is don't put it in a spot you're unwilling to make a mess, because if you're running that hopper completely full, you can spill out on that side, but then also just the cleaning process does tend to throw a fair bit of grain around. So on a maybe carpet, or have an area that allows for easy cleanup, or an area you don't mind making a mess. So in terms of cost, and I guess this is where the opportunity for these simple on-farms cleanings comes, is so it's made down in North Dakota, so it's nice to have a manufacturer who is just nearby, able to purchase them through Flamans with multiple locations here across Saskatchewan. Flamans, although they rent various things, they did not rent the Quick Clean. You may be able to rent from adjacent neighbors or others, but if you're purchasing them today, $13,500 for a 5-tube model, $15,500 for a 7-tube model. So it's not a huge difference between the two of them. You've either got an electrical drive for it, or they also have hydraulic options for them as well. Comes with one set of tubes. Tubes are not cheap though. They're like $250 a pop. So depending on which model you got, you're looking at $1,250 plus GST or $1,750 just to get different tubes. So if you end up having to run through tubes, A, you don't want to damage them. B, it can get a little pricey. So that's one of the I would say one of the challenges. In fact, I would say that kind of fits in those downsides. So if you're trying to make do with the screens that you have, you can lead to all sorts of frustrations. As you can see here in the picture, we were trying to clean something via the slots option, but we still had way too much wild mustard and wild millet. And then your slots are completely plugged with your dockage. Then that means grain is not coming through. And the only way to deal with it was kind of continuously trying to scrape them and clean them, but you have to remove them to do that. So that really doesn't work at all. As I say, I think the kind of cost of the tubes is kind of a definite bit of a downside, and they tend to ship out of North Dakota. And I've not found an alternative manufacturer to supply tubes. Maybe there's ones out there that can actually do it, more cost affordably, because it is just a tube with holes in it. Not that it's complex. There's definitely some, I would say one of the great options is the flexibility. So, easy to store away for the 50 months of the year or more that it's not needed. There may be some scenarios where you've got high dockage years and you're going to be using it on a variety of crops, and other years perhaps not. So you can just squirrel it away in the back of a small shop and not have to worry about it. Easy enough to just load on a flat deck. So you could, instead of having a fixed permanent setup, you can just move it between different bin storage locations if you're running multiple bin yards. You got opportunities to share or rent it with, other neighbors. We've been in the scenario where our neighbor really needed the quick clean, but we didn't have the right tubes, so they bought the tubes, and now we have options to use those tubes in the future. I think it allows for tremendous transformations. As you can see, the unholy mess on the left-hand side transformed into what is really, and I guess still obviously there's dockage. This was the tail end of the bin, so they're actually, of course, the thistles had mostly risen to the top. But when you think of dockage being done on a weight basis, the amount of weight that a handful of thistle heads and the occasional bit of grasshopper and or few larger kernels that escape through is pretty insignificant. So it certainly still visibly has dockage in it. The only options would be, to run it through, I'm not sure, with the quick clean, we couldn't have had another option, and it didn't matter because that met buyer specs, and we just extra work to try and remove something that wasn't needed. So if there's other questions, comments, we can definitely do that. But now my next question is, what do I, now that I've cleaned that unholy mess out of the peas, it's years like this that really create opportunity, I would say, with that, with the quick clean. Suddenly, in past years, I'd be like, whatever, just sell it as organic cattle feed. $150 a ton, great, somebody else take it away. Now look at that and hearing stories of $9 a bushel for pea splits, $12 a bushel for oats. Can I take and transform that mess and still yet create something marketable out of it? It's certainly, if I have to buy a new set of tubes for it, oh well, $1,200, that's going to get paid for if I'm able to transform that into a sellable product. More than covers it. I have a bit of an experiment from some flax wheat intercrop last year that I've tried to get cleaned up, hasn't got it there, was nearly ready just to dump it in the screenings bin. But I'm sure as you all might agree, I think with the price of flax right now, it's going to cover a fair bit of winter goofing around regardless. So that's, I think, really where it kind of I see the opportunities in some simple on-farm cleaning. And with that, we'll pass it over to Marla, or Deb for that matter.
Perfect. Thank you so much, Stuart. As your words for that nuts and bolts presentation, it's really helpful, I think, to see or to begin to understand how it can add value, right? So I was just thinking at Sask Organics and other provincial associations, we do a lot of, or we organize a lot of presentations on supporting growing crops, but that post-harvest grain handling is something that we don't focus on as much. And after you put all that effort into growing the crops, ensuring that you can maximize the value at the harvest end is incredibly important, and also important for food manufacturers, right? Because they have their recipes and the specifications that they need, right, to be able to make their consumer product. So it's just important all around. So thank you so much for that. And there just was one, it's not actually a question, but a resource. Zettler Farm Equipment in Portage La Prairie has used quick clean machines and tubes. So
got you. Well, Zettler's also is a spot where we end up purchasing the rotary screener used at the farm I was at previously. So yeah, they seem to have a good collection of used cleaning equipment as well as grain carts and a few other things. So yeah, I didn't realize they actually had tubes as well. So that's a good thing to know.
Yeah, no, excellent. Yeah, perfect. Okay, well, thank you again, Stuart, for taking the time to put together the presentation and being here with us today. So thank you so much. And we'll move on to our final presentation for today. And I'm handing over to you, Dwayne. Thank you so much.
Good morning. Thank you for the opportunity to talk to you today. We look forward to sharing you some of the things I've learned the hard way over the years. And Charley and Stuart, they were very good presentations. Look, I got a few extra things I wrote down because I was listening to you guys talk. Deb, if you can bring up the first picture.
Okay, just 1 second here, and I'm just trying to put your webcam on here. Are you getting a prompt there, Dwayne, in your screen?
My screen.
It should pop up in the middle of your screen somewhere. I'll do it again.
Yeah, I found it now.
Okay. And I will get your presentation up here. Give me 1 second. Okay, can everybody see the presentation?
We can. Thank you so much.
Okay, great.
Okay, thanks, Deb. So this is part of our grain storage. It was a annex off of an elevator that we moved in, probably 30 years ago. It has 10 bins in it and about a 60,000 bushel capacity. So I'll talk a little bit about storage and a bit about our grain drying systems we have on the farm. These bins are about 53 feet deep, so the grain's about 53 feet deep in there. We have put grain in there that has been at 14% moisture. It has gone in hot. If we do not turn it, when you go to take that grain out in a month or two, the bottom grain will be tested at 13% moisture, and the stuff at the top will be at 16%, and a good chance that you'll have crust on top that's starting to spoil already. So we do turn the grain in that system there, and it's quite easy for us to do because it's a drag in the bottom, drag in the top, leg going up, so we can simply push buttons, open slides, and turn from one bin to the next bin if we want, or turn it in the same bin. And the way I do of making sure I've got the top stuff right down to the bottom is we throw in some colored sheets of paper. And by the time they start coming through, you know you've got the top stuff all the way down to the bottom then. Now, in the rest of we also have probably about 32 steel bins that we use for storage. We do clean to food grade specs. So to make sure that the grain that goes into those stays clean, they go into smooth wall bins, no corrugated bins. We also put foam seals on any doors that are on them so that they seal like with a gasket, try and keep any flies or moths or anything out of them. We do have aeration fans on some of them, but we're just bought a bale burner that we're planning on setting up for adding heat to the drying system. And what it is it's like a boiler, and you'll be able to put in flax bales, old pallets, all kinds of junk like that, burn it. It will heat water, and then we will use a rad system to warm the air going into those bins. Also, on a year like this where we have not a great yield, but quite a bit of green weeds in the crop as we harvest it. The crop is dry, but the weed seeds are definitely not dry. So they will go into our rough cleaning bin, which we have a mobile cleaner. It is a eliminator that Flammon's used to sell and they used to rent out. And we'll run it through that, take out the green weed seeds, and clean up the grain a bit before it goes into storage. Now, as far as one other thing I was going to mention about when you use it, we also have a grain dryer, and it's a Vertec, and we have used it. The one thing you do want to watch when you use the grain dryer is the bounce back effect, and that is because you'll be testing your grain come out of the grain dryer and it will be dry, but because you've dried it fairly quickly with the grain dryer, the outside of the kernel is dry and the inside still has high moisture. And after you put it into storage, the moisture level will come back up. So you do need to over dry it a bit to get the right amount of, get it dry to what you want it to. Okay. As far as the cleaning plant, it is strictly for our own use. We do no custom cleaning. This is the other side of the building, the grain cleaning plants in that building, that shed there. We do clean pretty well everything to go directly to end users. So it is cleaned up to 99.9+% usually. We have not spent a lot of money on our system. We only have one piece of new equipment in there, and that is a dehuller, simply because you couldn't buy a used one like we wanted. This is all old used equipment that we have refurbished, made quite a few changes to the way they work. So our process would be to, first of all, go through our rough cleaner, which is the eliminator. Then it would come into the plant here, and first machine it would go into, just on the side of there, you can see a light brown machine. That is a grater that would run things through, and we would take out most of the small weed seeds. Behind that, it goes into an indent, and from the indent, it flows to another wind and screen. From the wind and screen, goes to a gravity table, and then the last machine you can see my son checking out is the destoner. And from the destoner, then it goes into our truck usually. There's a lot of changes we're going to make in this plant. We want to raise the roof. We would put some machines stacked over top of the other, and we have set up pretty well everything in our plant on wheels. So if we were going to switch to cleaning flax, we would roll one machine out and roll another one in rather than start changing screens and drums. There's not a lot of money spent in this plant. Everything is put together by ourselves pretty much. Quite a few, can you go to the next picture, Deb? Okay, well, this is one thing that I highly recommend when you build, if you're going to build a cleaning plant. This is a screenings drag and runs right through the center of the cleaning plant. And these are removable doors, or you can slide them down. So if you want to get rid of screens off of a machine, you simply open up a spot, let it go in. If you're cleaning up the building, you lift the panel out, sweep everything into there, takes it away and puts it into our screening system. There's one more picture, Deb. That one, that was the grader that I was talking about. We've done quite a few modifications. This one turned out looking like a man, not on purpose, but just by accident. This machine had just a gravity flow, and there's 4 different drums in there to feed. While it never fed very evenly, it would bunch, it would go in more into one, more into the other one. So my son built a system there where it goes into that hopper, and at the hopper, he has a drive up there with a roller that feeds it evenly into all 4 spouts and down to each individual drum. Another modification we made was our gravity table is a Forsberg, which was a variable speed drive. And if you've ever used a gravity table, they're very sensitive to the settings. With the variable speed drive, as it warmed up, the belt changed, the pulley drives changed. So we went to frequency drives, so we can vary the speed with electrically and by just adjusting knobs. We also dehull spelt. So from in that plant there, we can take out grain that's not hulled, and it goes up into another room where our driveway is through a dehuller, then through an aeration system to suck out all the chaff that's been dehulled, then through another grader, which will take out the clean grain and send it to a bin to be cleaned. And the stuff that didn't get hauled will go back through the system and be run through the dehuller again. When everything's running, we have a total of 34 motors running. So it's very important when you're building a plant to make sure you have enough power there. That has been a problem for us. And also make sure you make the plant bigger than you think, because you're always adding more equipment down the road. Another thing we've done on our farm is we've set up a lab to do our own testing. And so we're able to do moisture tests, protein tests, and also falling numbers. And this has been necessary because we're selling to end users. So as we clean the grain, we have to know what specs they are to go to different end users, because they all want different proteins, falling numbers, and moisture. We did play with intercropping, tried it for a couple of years. Love the idea of the way the crops grow and everything. The problem is in the end cleaning, when you're cleaning to 99.9 plus, broken chips of peas, broken chips of lentils, it's just too hard to clean and do a final cleaning on it. Hey, we also are able to fill totes and do bagging down to 25-pound bags on the farm. We haven't done any 50-pound or 25-pound bags now for a couple of years. We do some totes still, but most of it's going out in bulk now. Very seldom we have a call for anything else. I think that's about it. If you got any questions?
That's great. Thank you. Thank you for that, Dwayne. And thank you for giving us a look into your plant there on the farm in Assiniboia. It's always when we ask farmers what they want, to see, sort of like in our programs, it's always or what they benefit the most from. It's often hearing directly from farmers on what they're doing on their farms and what's working and what isn't. So for sure, anyone who is considering putting in some on-farm cleaning, and I'm thinking, Dwayne and I have known each other for quite a while, and so I know a bit about his operation. And I know that you sell direct to food manufacturers, and obviously when you're doing that, the sort of on-farm cleaning that you have, or the cleaning plant you have on farm, I should say, is makes that possible. So I guess if other farmers are considering that, that would be something that would help them, I guess, realize more value. And also you're in control then as well, which I think is probably an important part of that relationship as well.
That's a very important part. It's made it so that we're able to put a product together quickly for them, and we have far more control on the amount of dockage. We can we pull stuff off in places in the cleaning plant that we will take and re-clean that normally would have just gone out as dockage, and we can salvage different crops out that normally would be just going to waste. And we also run bison, so we have the option of anything that's not fit to be sold as screenings, maybe the moisture's too high in it, or like those green weeds, goes directly out to the bison and fed to them. So
yeah, no, for sure. And I was really, for me, what was interesting, or what I found really interesting was, along the floor of your cleaning plant, and how you're maximizing your screenings that way as well, was really interesting. And it looks like I have a question. Oh, was it a question come in or a chat? Sometimes the technology gets me here. I'm just going to check to make sure. Oh, the question is, Dwayne, was the system set up strictly for your own use, or do you plan on custom work for other producers?
no, our own use.
Yeah, I think I know the answer. Yeah, no, for sure. And again, just from the outside looking in, it's that being able to use the plant when you need to use it for your end users, right? So when you start bringing other folks in.
Yeah, well, last year, by the time we finished our dehulling and our cleaning, we had 24 hours before we started putting grain in the bin again. So we used the whole time ourselves. And I don't want to get into custom cleaning. That is a whole nother level of organic inspections and paperwork. And I have friends that custom clean. They can do that job with money.
No, absolutely. That completely, completely makes sense. Well, thank you so much, Dwayne, for sharing, like I said, sharing your experience and letting us see, have a peek into your operation. We really appreciate that. And also thank you to our previous speakers, Stuart and Charley. So looks like we're ending up finishing right pretty much on time, which is great. And now I'm going to, because I messed up earlier with my presentation, I am going to flip through all of my slides to get me to here to say thank you so much again to our speakers. Thank you to those who attended, and for those who will watch the recording that we're going to be sending out later today or first thing tomorrow. Just to remind you that there's a short survey that will pop up directly after the webinar, and we'd be grateful if you could take a moment or two to tell us what you thought. Your feedback is important to us and helps us plan for the future. And then just a little plug for a few things at Sask Organics. Past webinar recordings are available for purchase on our website. So the 2020 series is $10 and the 2021 webinars are at $20. And we're super excited about the Abundance Box. It's back again this year. It's been on sale for about, I guess, 10 days, and we're almost 25% sold. So I'm pretty excited. So if you're thinking about buying an Abundance Box, make sure you jump onto our website and grab one. And that concludes our session for today. So just thank you again. Thank you to our sponsors, Grain Millers, and for all these who are listening. So have a great rest of your day.